So let p be any positive number, so let p be greater than 0, where I'm going to define a specific type of series. So a general p series, is any series of the form summation n goes from 1 to infinity of 1 over a n plus b to the p, where a and b can be any numbers. So a and b can be arbitrary numbers. So this is the definition of what's called a general p-series. And a specific type of specific type is if a is equal to 1 and b is equal to 0, then the series is called, the series you get looks like this. Summation n goes from 1 to infinity of 1 over n to the p, and this is just called a p-series. So it's a specific type of a general p-series. So series of this form are called p-series. So you fix the power, and you're taking sums over these powers here. And so we'll do some examples, but what's nice about p-series is that there's a very easy result. We can just read off right away whether or not an arbitrary p-series converges or diverges. So let's give the statement here. So here's a theorem. Any p-series, so that means general or non-general, it will converge, so it converges if and only if the power is bigger than 1. So again, that means two things. That means if p is bigger than 1, it automatically converges, and then conversely, if p is less than or equal to 1, it diverges. So this is these are very nice series because it's not complicated to determine whether or not the series converge or diverge. So let's just do a couple of examples of p-series, and we can see whether or not they diverge or converge. Okay, so here, 1 to infinity of 1 over n. So in the previous video, I told you that this series diverges, and I said that this was called a harmonic series. Harmonic series. Sorry, just so you know, this is called the harmonic series, just so you know. But here, this is clearly a p-series. This is a 1 series, because certainly this is the same thing as, it's just 1 over n to the 1 power. You can put a little 1 there if you want. Exponentiating to the 1 power doesn't do anything. It's a 1 series, and therefore it diverges. It diverges. Okay, because that's the general p-series test. It converges only if the power is strictly bigger than, if p is strictly bigger than 1. So this series diverges, because p in this example is 1. What if we did this? summation n goes from 1 to infinity of 1 over n squared. So this 1 over n squared. So this, in this case, this is a 2 series. So this is a what's called a 2 series. And therefore, it converges. Now notice that what that means is that we can actually sum up all these numbers, but it doesn't tell us what that total summation would actually equal. So it only tells us that the series does converge. It doesn't tell us any information about what it converges to. So again, we're just using this test here. A p-series converges if and only if p is strictly bigger than 1. What if we had something like this? Summation n goes from 1 to infinity of 1 over the square root of n. So we can just be explicit using exponential notation. We know that square root is the same thing as exponentiating to the 1/2 power. So this is a 1 over 2 series. And of course 1/2 is not bigger than 1, so it diverges. So it diverges. And let's do an example of a general p-series. Let's say summation n goes from 7 to infinity, say 1 over 2n plus 3 to the 5th power. This is a, well, it's a general, that's okay. This is a 5 series. And therefore it converges. So these p-series are very nice because we can determine automatically if they converge or diverge just by looking at the fixed power.